The next question is, a piece of plasticine and a ball bearing of the same mass are dropped vertically downwards from the same height onto a hard metal surface. Part 1. Explain whether the plasticine or the ball bearing which would exert a larger average force on the surface. All right. Part 2 will be calculate the average force exerted by the plasticine and ball bearing. Okay. If the mass given as both 10.0 grams, height 2.0 meters, and the duration of impact is 0.02 seconds. So basically, this is the question. So let us first picture that. So what is given to you? You're given two objects, one plasticine and one ball bearing. So let us put that. So plasticine, that's plasticine. Always picture, imagine, and make a simple sketch. With that, your understanding will be better. And then you have your ball bearing. Okay, this is your ball bearing. All right, conceptualize first. Okay, all right, this is your metal surface. So let me put one single metal surface. All right, okay, this is your metal surface. All right. So now your plasticine is dropped from a height of 2 meters. It's dropped from a height of 2 meters. Okay, so that's your height of 2 meters. So 2.0 meters for both. Both are of the same height. So since both are the same height, let me redirect the ball bearing. Okay, so that you know it's both the same height. Huh? So let me redirect the ball. Okay, so keep it. So this is ball bearing. Okay, I put it in this. So that you know it's the same height. Okay, both are. All right. So the examiner wants you, first of all, to explain, all right, which would exert a larger average force on the surface. So what force are we talking about here? All right, the force we are talking about here is force during an impact. So force during an impact is what we know, what we call or term as impulsive force. So they're talking about the impulsive force. Now, many of you or many students do not understand the sequence of events that occurs. So this is where you got a slow motion and thinking process and sequence what is happening. See, what is happening is when you drop the plasticine, so let me put this for you. So the initial velocity is 0, same goes here, the initial velocity is 0. Then both the plasticine and the ball bearing assumed to have experienced what we call free fall. So they are assumed to experience free fall, both of them free fall. Therefore, this will fall at an acceleration equivalent to g, which is 9.81. This also falls with a constant acceleration g. Now, this is our assumption. All right, until just before it impacts. All right, it achieves a maximum velocity, which is your v. That will be the final velocity. All right, just before it impacts, it achieves a final velocity which is v equals to final velocity, which is a maximum, which we do not know, but we can calculate. Why we can calculate? Because we got the height. When you have the height, you know your g, you know your initial velocity. All right, your kinematics should have taught you. Yes, we can calculate, but we are not interested at the moment to calculate yet. Okay, all right, because examiner only wants you to compare. Okay, so is the impulsive force exerted for the plasticine? Remember, when the plasticine hits the metal surface exerts the impulsive force on the plasticine, and the plasticine will exert the impulsive force on the metal surface. So the plasticine first exerts the impulsive force on the metal surface. You can term that as action. And as a response, the metal surface exerts a reaction force on the plasticine. Both are impulsive force. All right? Okay. Both will be equal, but in opposite direction. That's that. My point to you is the impulsive force exerted during its fall? This is where many of you do not know. Here, there is no impulsive force. Impulsive force do not come about during the falling process. There is no impact. So some of you mistakenly take that as your initial velocity and that's your final velocity. Sometimes coincidentally the answer is correct, but your physics is wrong. you have to know that the impulsive force is not during the fall. This is free fall. The impulsive force is upon the impact. And this is where you have the impulsive force. This is where the force comes in. So the average force stated is actually the impulsive force during the impact. Yeah. All right. So that means this V is actually the U for the calculation of the force. For the calculation of this force, that's the U actually. This is the V for the falling process. For the falling process, initial, final. But during the impact, that final becomes the initial. Same goes here. This is actually the initial. So the concept of physics must be understood. So you got to sequence the events in order to capture this point. All right? Okay. Number 2, your plasticine and ball bearing. Now let's examine the materials. That's a soft materials, equivalent to an elastic material. That's a hard material. So the hard ball bearing, upon striking the metal surface, will have the bouncing effect. Whereas the plasticine, upon striking the metal surface, will not bounce off. It will stick, which means the final velocity of the plasticine is expected to be 0. Whereas the final velocity of the ball bearing is not 0, because the ball bearing will bounce off, and here we assume elastic collision. See, when examiner has not given us that it's inelastic, you always assume ideal conditions. In physics, that's what you call a convention. When abnormal conditions are not given, non-ideal conditions are not given, then you have to assume it's ideal condition. Like for example here, free fall, because they never talk about resistance. Although they did not mention resistance is negligible, it's only fair you think about free fall. Otherwise, we can't solve. And then here there's no problem because it straight away stops. The plasticine keeps the metal surface, stops, does not bounce back. Here it bounces back. When it bounces back, there's a concern about what type of collision is it. Because if it's inelastic, it will not bounce back with the same velocity. That means this velocity, let's say this is 2 meters per second. So when it bounces back, it will be minus 2 meters per second. If it is elastic collision. If it's inelastic, 2 meters per second, when it bounces back, it will not be -2. It can be -1.8, 1.6, we do not know. So that we cannot determine that. So if a calculation is required, we cannot determine that. So it's only proper for us to think as elastic collision. Therefore, it hits at V, it bounces back at -2. All right? Okay. So let us stick to this V. Let us stick to this V as the U. So I'm going to remove that question mark. Yeah. So I'm going to take that as V. And since it's downwards, let's take the downwards as -V. That means the final velocity upon striking the metal surface is -V. And the final velocity here is V equals to 0. Remember, this is your U, that's your U. And here, -V. So upon going up will be V. So this is your U. This is the U for the ball bearing. That is the V for the ball bearing, and that's the U for the ball bearing. Okay, that's a U. So the U of the ball bearing is -U. The V of the ball bearing is V. Okay, so now we have got the whole concept. So let us simply do a simple mathematical verification here. So the force of impact will be mass of the plasticine, final velocity of the plasticine, which is 0, minus initial velocity, which is -V, divided by time of impact, which I do not know. All right, time of impact, I do not know. I put it as T1. Okay. All right. Force. Okay. Mass. This one will be V minus V. Time of impact, I do not know. All right. this gives you 2 mv over T2. This gives you mv over T1. So now let's come to the question. Between the plasticine and the ball bearing, okay, which one will give you a greater change of momentum? Sorry, greater force. Is it the plasticine or ball bearing, or is it both the same? So here we further analyze it. The force is directly proportional to the change in momentum. This is more of the change in momentum, but inversely proportional to the time of impact. Inversely proportional to the time of impact. I put a general time here, time of impact. Here, I put it as change in momentum. So I put it like that. So you know the change in momentum of the ball bearing is double, 2 times. You can see here, look at my finger, 2 times the change in momentum there. All right, you know that. Number 2, you know that the time of impact, that means your T1, let me compare, your T1 and your T2, your T1 will be longer than your T2 because it's a soft material. So soft material, upon impact, there'll be a lot of cushioning, and therefore T1 will be definitely longer than T2. Definitely longer than T2. Okay, T2 will be shorter. But you can assume it for your discussion purpose. You can say, okay, let the time be the same. So even if the time is the same, all right, the momentum, the change in momentum experienced with the ball bearing is much higher, in fact, double than the change in momentum of the plasticine. Therefore, your verdict should be your ball bearing will exert a bigger force, impulsive force on the metal surface, and therefore will also experience a bigger impulsive force compared to the plasticine. All right. Now, if you want to bring the time into consideration, you will find that actually this time of impact is definitely longer. This time of impact is definitely shorter. So if you take the time of impact, which is inversely proportional, the average force exerted by the ball bearing is yet again bigger than the plasticine. So either way you see, it is the same concept. All right. All right. So that is what we are going to talk about. So that means now when you are going to explain about the average force, you are going to say that the plasticine, you're going to say that the plasticine and the ball bearing will undergo a bigger change in momentum due to this bouncing effect. Point number 1. Point number 2, the time of impact of the ball bearing will be shorter. The time of impact of the plasticine will be bigger. And then you bring in your physics concept. The relationship between the force and time is inversely proportional. So with that relationship, yet again, the average force exerted by the ball bearing or on the ball bearing will be bigger than the average force exerted by the plasticine or on the plasticine. And you conclude your discussion. All right. Okay. So now you can take now. Okay. I'm going to give you the explanation. Huh?